All right, so today we are looking at kind of the last steps of compositions of functions. So far, we've looked at how to substitute a function in, how to evaluate it from there and put it in its simplified form. But today we're going to look at what happens when we actually know the value of x for a specific function, okay? And there's actually one of two ways we can go about this. The first way, let's treat this like we have been treating our composition of functions. Let's just place, this says, given f of x and g of x, they want g of f of x. They want g of f of x. So originally we would have said g of, and we would have replaced it with this, 2x squared plus 5x plus 13 is equal to, and wherever we saw x, we would have replaced it with what we just put in parentheses. So 3 times 2x squared plus 5x plus 13, and then all plus 14. And then from there, we would have just simplified, we would have distributed, and we would have 6x squared. 3 times 5 is 15x. 3 times 13 is 39 plus 14, and then we just combine like terms, and we're going to get 6x squared plus 15x, and then 39 plus 54, or 14, sorry, is going to give me 53. And that's kind of where we would have been at. And here they're telling us, well, what if x equals negative 1? What if in our original x equaled negative 1? So let's see what happens if I just place it into this. Wherever I see x, I'm replacing it with a negative 1. So 6 negative 1 squared plus 15 times negative 1 plus 53. Well, negative 1 squared is 1 times 6 is just 6. Plus, or rather, 15 times negative 1 is negative 15 plus 53. And we put that all together, and what we end up with, 53 plus 6 is 59, minus 15 is 44. 44 is where we end up. Okay. Now, this is how we have been doing things. Let's see what happens if instead of doing all of this, we're going to take a step back, and they tell us that f of x equals negative 1. So I am going to start with f of x. I'm going to do it right here on the left in blue. I'm going to start with f of x, and I'm just going to replace the x with negative 1. So in parentheses, negative 1 squared plus 5 parentheses negative 1 plus 13. And we're going to solve for this before we ever get to g of x, because g of x is where we want to end up at. So we're going to solve for this. Negative 1 squared, of course, is just 1, times 2 is 2. Negative 5 times negative 1 is negative 5, and then, of course, plus 13. And from here, we add our terms together. 2 and 13 is 15, minus 5 is 10. Now we're going to take this 10, and the same way we put f of x inside of g of x, we're going to take that 10 and we're going to put that in for g of x. Because this 10 represents all of f of x. We are substituting it in. So let's see what happens when we put that in. If I say that x equals 10 for g of x, that means wherever I see x, I'm replacing it with a 10. So 3 times 10 plus 14. 3 times 10, of course, is 30, plus 14. We add those together, and we get 44. As you can see, we got the same solution for both, okay? What we have learned is if we don't know the actual input for any of the functions, and we are looking at a composite, we can arrive at a simplified version That's that 6x squared plus 15x plus 53. And this actively combines the two and allows us to get whatever output we need based on what x is. And that's why we have covered this. And you can see here we were given what the final output should be based on an input of -1. But here we saw, and this works for one function only, what happens when f of x is actually -1? What happens when that's -1? Here we got a function where no matter what x is to start with, we can solve and get the same answer, or not the same answer, but rather the correct answer every time. Here we saw what happens when I start with a specific answer here and then plug it in to g of x, okay? Both ways provide me with the correct answer. Whatever you're more comfortable with is 100% up to you. If you want to follow the steps that we've done so far and plug in the whole function, get something simplified, and then substitute, you can. Or if you want to substitute into the function, solve, and then plug it into the last function to get your output, you can do that as well. So it is completely up to you what you want to do. If we look at number 6 now, we are given f of x and g of x. Sorry, I had a little tablet trouble there for a second. And they want f of g at 2, okay? Remember, whatever's first is what you're going to end up with. It's going to be the thing that you're solving at the end. So whatever's second, that's what we're plugging into. So for this example, I'm only going to do what we do if we have a value. So here they are telling me that x is 2, and since f is first, we're actually going to work out g. Whatever's second is what we're going to work out. So wherever I see x in g, I am going to replace that with 2. So x squared, that's going to be 2 squared plus 6x, so 6 times 2 minus 9. And then we're just going to solve. 2 squared is 4, 6 times 2 is 12, minus 9. 4 plus 2 is 16, 16 minus 9 is 7. And then we're going to take that 7, and in f of x, we are going to replace x with 7. So I can say f of x, or rather f of 7, is equal to 7 plus 6. 7 plus 6 is 13. So my final answer is 13. Okay. I know this is a lot quicker than probably what we're used to, and that's fantastic for us. That just means that we're going to be more comfortable with this, hopefully. I hope this helps you. Again, I want to point out, whatever goes first, that's the last problem we're working out. Whatever goes second, that is what we're going to substitute the 2 into. We're going to solve, and with that solution, that's what we're going to put into whatever's first. So 13 is my answer here. I started with x equals 2, plugged that into g of x, found out what g of x equals when x equals 2, and then using that answer, we went back to f of x and solved. All right, I hope that helps. You have a great day.